Hey guys, welcome to Chapter 8, and this is all about right triangle trig and applications of non-right triangles. Okay, so 8.1, we're talking about right triangles still. So, good old SOHCAHTOA. So just a reminder, if you guys want to look over all the trig functions and their reciprocal functions, and given this triangle here, what the side ratios are. But pretty much you just have to know SOHCAHTOA for these. Okay, so you guys can look over that. All right, first thing is the complementary cofunctions theorem, which says that cofunctions of complementary angles are congruent. Okay, so first of all, from geometry, did you guys remember that complementary angles are ones that add to 90 degrees? Okay, so this theorem only works when you have two angles that add to 90. And the two trig functions have to be cofunctions. So it turns out sine and cosine are cofunctions. Tan and cotangent are cofunctions. And secant and cosecant are cofunctions. Don't get these confused with reciprocal functions. Okay, so now let's use the theorem. So if you guys were given this problem, no calculator, and we learned on a test that you cannot just add 40 and 50 and make it 90. So let's see how we can apply this theorem. So would you guys agree? I'm going to pick this one. Would you guys agree that sine and cosine, and I'm just going to do squared, are cofunctions? And if their angles are complementary, then these are going to be this equal to each other. So like if the angle's 40, then the complementary angle would be 50. So what I'm saying is these are congruent. Sine of 40 is equal to cosine of 50 because they're complementary cofunctions, and it also works for when they're squared. Okay, so I just replace this with an equivalent form, and now I can solve this problem because if you sin, it'll cost you 1. If the angles are the same, cosine squared plus sine squared always equals 1, regardless of the common angle. All right, so that's a little bit about complementary cofunctions. All right, on to solving a right triangle using SOHCAHTOA. So this one, let's see. Let's say you have to find, solving a triangle means find anything that's missing. So I'm going to start by finding angle B. If the angles in a triangle add to 180, what's 180 minus 90 and 40? And you end up getting B is 50 degrees. All right, so one thing down. Now we have to find the missing sides. So using the reference angle 40, and you could also use the reference angle 50 if you want, if I have the opposite and the adjacent, I'm going to use tan to find side A. Okay, so tan of 40 equals A over 2, because this would be opposite and this would be adjacent. So TOA. And then if you guys cross multiply, now notice we're in degree mode, so make sure you guys go to degree. And then yeah, just cross multiply. Tan of 40, close it off, times 2. And then it looks like side A is going to be, they don't say how to round, so I'll just do 1.68. So side A is about 1.68. All right, now we're going to jump into side C. Now using the 40 again, using the side C, we have the hypotenuse and an adjacent. So when we have adjacent and hypotenuse, I'm going to use cosine. So cosine 40 equals 2 over C. And then you're going to cross multiply. Now this one, when you guys cross multiply, we actually have to end up dividing, because it's going to be 2 equals cosine 40 times C. So to actually solve for C, we have to divide both sides by cos 40. Right? So that'll be C. So this one 2 divided by cos 40, you end up getting about 2.61. All right, so that's just simple solving a right triangle using trig. All right, so this one's just a word problem, but it's really the same thing. Okay, so go ahead and read this, and then when you're ready, you can unpause it and we can see how to set this guy up. All right, so what are we trying to find? What is the width of the river here? So we have the angle, and we have the adjacent side, and we're trying to find the opposite. So when we have opposite and adjacent, what trig function is that going to be? That's TOA, right? Tan. So it's tan of our angle 20 equals b over 200. And then just cross multiply. So 200 times tan 20, so b is about 8. And then since it's a word problem, we want the units. What is this? Meters. So about 8 meters. Oh, I just realized I typed it in wrong. What the heck did I type in? 200 times tan of 20. Sorry, that is 72.79 meters. Sorry, I totally typed that in the calculator wrong, and I'm not restarting this video, so we can deal with it. All right, awesome. So the width of the river is 72.79 meters. That makes a little more sense. Okay, turn the page. Let's do one more, and then we'll save number 5 for class. But feel free to try it if you guys want. Okay, so what's happening here? So go ahead and read the story. And let's use trig to solve for angle B. Okay, so this time we're trying to find an angle. All right, so it looks like the height here is 3,100. So that's the opposite side length. And then it looks like the hypotenuse here is 14,100. That's the hypotenuse. And they want to find the angle that creates that triangle. Okay, so they're calling that the inclination grade of the trail. Okay, so when we have an opposite and a hypotenuse, that's O over H, that's sine, right? So sine of our angle B equals 3,100 over 14,100. Now, if you guys remember from Geo last year, if you're missing an angle, you do inverse trig. So we're going to do inverse sine, 3,100 over 14,100. Okay, so this gives us angle B is 12.7 degrees. And that's it. Now, some of you might have been like, how do we know? This is also 8,000 here. And then that means the total height was 11,100, but we only want to use the number on the actual triangle. So we can use the right triangle trig. All right, guys, feel free to try number 5, but I'm going to stop here and save that one for class. All right, thanks for watching.